Ever wondered why a spring bounces back to its original shape after being stretched or compressed? Or why a rubber band snaps back after being pulled? Welcome to the fascinating world of physics, where a simple principle known as Hooke's Law can answer these questions. Hooke's Law, named after the 17th century physicist Robert Hooke, is a fundamental principle that governs the behavior of elastic materials. It explains how materials respond to applied forces and how they deform under stress. At its core, Hooke's law states that the force needed to extend or compress a spring or elastic material is directly proportional to the extension or compression of that material. Break it down, and it simply means that the more force you apply to a material, the more it will stretch or compress. This relationship can be mathematically expressed as F equals negative K times X. Here F represents the force applied to the material, K is the spring constant indicating the stiffness of the material, and X is the displacement from the material's equilibrium position. The spring constant is an essential parameter here. A higher spring constant points to a stiffer material that requires more force to deform, while a lower spring constant implies a more flexible material that deforms easily with less force. Hooke's law isn't just a theoretical concept, it has practical applications across various fields. It helps engineers design springs for specific uses in machines and devices. It describes the behavior of elastic materials like rubber bands, metal wires, and even human bones. Civil engineers rely on it to analyze and design structures like bridges and buildings, ensuring they can withstand various loads while maintaining their structural integrity. However, it's important to note that Hooke's law has its limitations. It's only valid within the elastic limit of the material. Beyond this limit, the material may experience permanent deformation or even failure. For instance, rubber has a significant elastic limit, while brittle materials like glass have a very small one. So Hooke's law is more than just a principle in a physics textbook. It's a fundamental concept that helps us understand the behavior of elastic materials under force and offers insights crucial to various fields of science and engineering. It enables engineers and researchers to effectively analyze and design structures and devices that rely on the properties of elastic materials. From the spring in a pen to the suspension bridge you drive on, Hooke's law is at work, silently shaping the world around us. It's yet another testament to the beauty and practicality of physics. It's a reminder that even the simplest principles can have profound implications.